Okay, we're going to graph this sine function. So the first thing we're going to do is find out what the amplitude and the period are. So the amplitude has to do with the number in front of the sine or the cosine. So the amplitude equals 3, but it's a negative. I like to write it like that. So that just, a positive sign goes up, a negative sign starts by going down and coming up, okay? So I recognize that first. So let's go ahead and draw it, and I'll show you how I even draw out my graphs first. So I know it's going to be, I can see that it's going to be shifted down 2. I'm sort of anticipating what's going to happen. That negative 2 means I'm shifting down 2, right? So I'm going to draw this here a little bit up higher because I know I'm going to have to shift it down 2. Okay. So my midline, I'll just go ahead and draw my midline in. My midline is going to be at negative 2. So here's negative 2. So this is 0, this is negative 1, so this is negative 2. That's my midline, and I'll even make it a little bit of a dotted line so you can see that it's actually not a part of the graph. It just helps me kind of know what my graph looks like, okay? All right, and then I know it's going to go up to, it's going to go as high as, I'll use a really light color so you can see, it's going to go as high as positive 1. Can you see that light blue? Yeah. And it's going to go as low as negative 3. I actually prefer just kind of to really lightly draw those lines in, okay, so that I know kind of where my values are going to end up. Okay. All right, and I know it's going to start by going down because it's a negative sign. So I'm just going to remember that before I do anything. All right, so that's just setting it up. Now for the trickier parts. The trickier parts are the period and the horizontal shift. I just took care of the vertical things. The amplitude and the period are the vertical things, right? You get that. The period and the horizontal shift are the horizontal things, and those are a little bit trickier to figure out. So first of all, let's talk about the horizontal shift. The horizontal shift, what I prefer to do if you have the problem, especially if you have it written like this, is take what's inside the parentheses and set it equal to 0 and solve it. So set that equal to 0 and solve it for x. So add pi to both sides and then multiply by 3. And that means it goes, whoops, I wrote 3x, 3 pi. That's my preferred way of doing it. It makes it a lot easier in my opinion. So that means I'm shifting, now notice, that's a positive 3 pi. But that means I'm shifting to the right because I solved it. Okay. Because I solved it. Normally your problem would be like this, right? If it was like x minus 2, which way would that be shifting? That would be shifting to the right. So if I set this equal to 0, it would be x equals positive 2, and that's shifting to the right. Okay, so when I set the inside, remember when you did transformations of regular functions, you could have just set the inside equal to 0 and solved it, and then not worried about left and right stuff. Always just positive is right, negative is left. Okay. So that's how I prefer to do it with sine and cosine. So I know I'm gonna, it's gonna be shifting 3 pi to the right. So here's what I like to do. I like to call this line right here. I take this line, this what previously was the x-axis, or sorry, the y-axis, and I make a dotted line, and I call it 3 pi. I call this, instead of 0, I call it 3 pi. Because it needs to start there anyway. Now if I had a big piece of paper, I would draw my y-axis way over here to the left. But I don't even have room for that, so I'm not even going to bother about drawing it. No, it's really not necessary to draw it. Okay? So the next thing is, so that's where I'm going to start. In fact, to be honest with you, what you can do right now is you can just draw in your graph. Now that you're done, you can actually draw your graph. You know it's going to go. So I always like to break it up into 4 equal sections. So this is 1, this is 2, this is 3, This is 4.
Wait, I have a question about that because my teacher, I always thought it was 4. Then for some reason he would put
there's 5 values, right? Oh. Here's your first value, second value, third value, 4. It's called the Fencepost Theory. If you have 4 segments, there's 5 points because you have fence posts on the end. Does that make sense? So here's 1, and then there's 3 in the middle. So there's 5 values, but there's 4 intervals, which is a very good thing to point out for you to recognize. So I'm just visualizing those, right? As I go, I'm going to go ahead and actually I'll keep those values in there, but I'm going to take off the 1, 2, 3, 4 because those values you don't put 1, 2, 3, 4 in there. Okay, so I'm going to go ahead and draw my graph in because I can do that now. So my graph is going to look like this. It's going down, right? So it's going to start here. It's going to go down. It's going to come back. It's going to go up, and it's going to come back. Because that's what a sine graph does when it's negative. It always goes through the center line, the midline, in points 1, 3, 5, right? And it goes peaks and valleys on 2 and 4. And so here's my graph. Oh, that's really bad. Let's see if I can draw it. Roughly, that's my one sine. That's one interval of my graph. And of course, it would keep going, right? But a lot of times they just say draw one interval. All right. So now the question is, the hardest question for most people is, well, what are all these values here? Yeah. We know that's 3 pi, but what's this value and this and this and this? What are those values? All right, so that's where you deal with the period. Your period equals 2 pi over b, which is 1/3. So simplify that and you get what?
It would be 2 pi.
Dividing by 1/3 is like multiplying by 3 over 1, which is 6 pi. So my period is 6 pi, which means it's going this whole distance right here. This distance is 6 pi. That's 1 period. So how do I break 1 period up? Well, it kind of depends on the problem. This problem, you could probably just add 6 pi to 3 pi. That's the easiest thing to do. So you know this has to be 9 pi.
Wait.
Because I know I started at 3 pi, and this total distance was 6 pi, so that has to be 9 pi. And then the question is, what are each of these little distances here?
Yeah.
Well, those distances are 1/4 of the total period. So this interval, your interval length, take your period and divide it by 4. So my period is 6 pi over 4, so that's reduced. It's 3 pi over 2. And then it's just a matter of adding those to each of the values. And there's various ways of doing that, but right here you can just say, well, what's 3 pi plus 3 over 2? Well, convert 3 pi. I'll do the math down in the lower right-hand corner. 3 pi plus 3 pi over 2, right? Because this is your interval length, right? So I'm taking 3 pi and adding 3 pi over 2. Got it? 3 pi is the same as 6 pi over 2. Get common denominator. So that's 9 pi over 2.
Okay.
So this value right here is 9 pi over 2. And then add that again. 9 pi over 2 plus 3 pi over 2 equals 12 pi over 2, which is the same as what? 6 pi. And then add it again. 6 pi is like 12 pi over 2 plus 3 pi over 2, which is 15 pi over 2. So that's 15 pi over 2. And you're done. Now there's other ways to do it. How do you find a midpoint if you know 2 values? I'll do this in black again. What's the midpoint of 3 pi and 9 pi? Remember the midpoint formula?
No.
You add them together and divide by 2. That's called the midpoint formula. So what's 9 pi plus 3 pi? 12 pi over 2, which is what? 6 pi. So what's the midpoint? 6 pi. And you can do it again. 3 pi plus 6 pi divided by 2 is 9 pi.
It's kind of easier.
It is kind of easier in this example. But in other examples, it's harder to do that. So you just have to be flexible and have different ways. What's 6 pi plus 9 pi? I'm finding the midpoint, 15 pi over 2. Okay, so midpoint formula is a really good thing to remember.